Hello again, everybody, and welcome back. This is going to be section 4 of chapter 2, solving equations with variables on both sides. The last section we just looked at variables on one side, but now we're going to have them on both sides. Our objective here today, again, just to solve equations in one variable that contain variable terms on both sides of an equation. Before we get started, here's our warm-up questions. There are 6 of them here. Hit pause, take a second, go through and try them on your own, and come back and check your answers. So going over the answers real quick, this is just a simple number 1 here, combining like terms. 4x and 10x is a negative 6x. Number 2, you have to distribute negative 7x and a positive 21, and that's our answer actually, negative 7x plus 21. Number 3, another distribution problem, distributing the 1/3. Our final answer here is going to be 2x and positive 3. And this one here, you're subtracting or distributing the negative. So this would be a negative x and a positive 2. So you combine like terms here, the 15 and the positive 2. And you'll get 13 minus x. Or negative x plus 13, it doesn't matter. Number 5 and 6 are just solving equations. Answer here for number 5 is 2 for x. And for number 6, your answer is 28. Okay, so let's move on to new stuff. So here we have an equation that has a variable on both sides. You have 7n on the left and 5n on the right, and then you have the minus 2 on the left and plus 6 on the right. We're going to stick to our same non-traditional method here. There's a way, the traditional method would tell you to, add 2 to both sides and then subtract 5n from both sides. I'm not getting into that. I can show you that in your own time if you like, but I'm not really worried about that. What I'm worried about here is keeping everything down the middle with our warp zone. And a lot of these you're going to see a lot of arrows. I hope you can keep it together. But I like to keep all of my variable terms on the left. So I'm going to take this 5n that's on the right and I'm going to bring it over. And when I do, that's going to be a negative 5n. The positive 7n is going to stick around. Now I'm going to take this negative 2 over here to the right. So we're doing a lot of side switching through the warp zone. That 6 is going to stay, but now this is going to change to a positive 2. Remember, when you change a side, you change its sign. Make sure you just keep on that. Now it's real easy. Now all you have to do is a small, just combining like terms here. So you have a negative 5 and a positive 7. That leaves us with a positive 2n equals a 6 plus 2, which is just 8. Now we're going to have to finish up here a simple division. We're going to divide both sides by 2. So my final answer here is going to be n equals 4. Let's go on to the next example. So here again I have 4b plus 2 equals 3b. So I'm going to move all my variable terms to my left. So that means this 3b here is got to move. Let me give you the warp zone here, the interchange, or whatever you want to call it. So this is going to be 4b on the left. Here we go. 4b, and I'm going to have a minus 3b. And I kind of didn't leave room for the 2, but that's okay because the 2 is going to the right. This positive 2 is going to the right and become a negative 2. So I'm just going to combine like terms here. 4 minus 3, that's b, equals negative 2. Well, it's actually 1b, but you don't have to write the 1 there if you don't need to, you don't want to. So there I'm actually done with my final answer. 1b, or b, equals negative 2. Here we got some decimals to look at, but that's okay. We're going to do the same method. Variable terms got to go to my left, so this one here has got to go over here. So this will be a negative 0.7y. This is going to just drop down, stay on the same side, 0.3y. Equals, now this one over here doesn't have a number or letter to it, so it's got to go to the right. So that would make it a negative 0.5. It's not there anymore, and that is not there anymore. And this is going to be a negative 0.3. It's not going to change, so it's going to drop right down. So combine like terms, I'm going to take the 0.7 here and the 0.3. I'm going to subtract those. Signs are different, so I'm going to subtract. So this is going to be a 0.4. Negative 0.4. Let me put a 0 there. Y equals 0.5 and 0.3. Signs are the same there, so I'm going to add and keep the common sign. The common sign is negative 0.8. So now to get rid of the thing in front of my y here, I'm just going to divide both sides by a negative 0.4. Okay, negative 0.4. You probably have to go to your calculator for this, and that's quite alright. So I get do 0.8 divided by 0.4, and I get 2. Y equals 2. Another example here. Now this one looks complicated, and it really isn't, but it's just a little bit of some work we have to do. And for these ones, you got to keep in mind of your order of operations. And what I mean by that is, well, please, parentheses comes first, and we actually do have parentheses. We have to distribute first before we can start switching sides. And I see some distribution right here on the right side of this equation. So before we move anything, we're going to distribute. So I have to take and multiply negative 5 by both the 7 and the negative 2a. So I'm going to rewrite this whole thing. 4 minus 6a plus 4a equals negative 1. Alright, now I'm going to do negative 5 times 7. That's going to be negative 35. And then negative 5 times negative 2. That'll be a positive 10 and then an a. So now what I can start doing is start switching sides and changing things up. So I'm leaving all my variable terms on the left. So my negative 6a is going to stay put. This is going to stay put. But I need this 10a to come over here. So I'll have a negative 10a minus 6a plus 4a. Now I didn't leave any room for the 4, but that's okay because this 4 is going to go over here. And it's going to join the negative 1 and the negative 35. So negative 1, the negative 35, and now I'm going to have a negative 4 over here. So now I can just combine like terms. I got all my a's on the left, all my numbers on the right. So I have negative 6, or negative 10 and negative 6. That's negative 16a. I'm going to do this as just 2 steps, just to stretch it out here. And then negative 16 plus 4, that's going to be a negative 12a. Now over here, negative 1 and negative 35, that's going to be a negative 36 minus 4. And this is going to go a little more. This is going to be negative 36 minus 4, so that's going to be negative 40. Now I'll just divide here both sides by negative 12, negative 12. So 40 divided by negative 12 is, pull out that calculator once more, 3, well, let's reduce. I actually want to reduce. I'm going to divide everything by 2. I'll divide everything by 4. 10 over 3. There we go. So we'll do negative 10. Well, actually, these are both negative, so we can make these positive. So let's go back here and erase. So I have 10 over 3. And that does equal 3.3 repeating. But I always like answers in fraction form. Okay. This one we just did. There we go. Next one here, we have to distribute. So let's get on that. We're going to do this 1/2 to both of these. So 1/2 times b is just going to be 1/2 b. That's not going to change. But then we're going to do 1/2 times 6. Now I'm going to do this straight out here. 1/2 of 6 is going to be 3, just to save some time. 3/2 b minus 1. So I'm going to switch my sides here. This b is going to go over here, and this 3 is going to go over here. That'll be a negative 3, and this will be a negative 3/2 b over here. And that first term will stay positive, and that goes away. So to rewrite this nice and neat here, I have negative 3 over 2b plus 1 over 2b, all equaling negative 1 minus 3. So negative 1 minus 3 I can do real quick here. Actually, I'm going to move this down just a bit. Negative 4. So now I have negative 3/2 plus 1/2. Those are going to be different, so I'm going to add. Good thing with common denominator. I'm going to add, or I'm going to subtract, keep common sign. So that's going to be 2 over 2. Keep the sign of the greater number, I guess I should say. 2 over 2b. Actually, 2 over 2 is going to equal 1. So this is going to be a negative 1b equals negative 4. Now, even though this is a 1 in front, I can't leave it as a negative 1. That's not right. So I have to divide both sides by negative 1. And my final answer is going to be b equals 4. Let's keep on going. Here's another one here. Now, I know fractions in this one, but we'll still have to distribute on the right side first. Here and here. So this is going to have 3x plus 15 minus 9 equals 2 times x is 2x. 2 times 2 is a positive 4. Now we can start switching sides here. Let's see. This is going to go over here and be a negative 2x. So that's gone. Now I have to take two of these. I have to take this positive 15 over here and make it a negative 15. And I've also got to take this negative 9 over here and make this a positive 9. So once I switch the sides, switch the signs. So let's rewrite this nice and neat here. Negative 2x plus 3x equals 4 minus 15 plus 9. Okay, so negative 2x plus 3x, that's going to be a 1x, so that works out nice. 4 minus 15, well, let's do we to subtract because they're opposites. One's positive, one's negative. Subtract, keep the sign of the bigger. So that's going to be a negative 9 plus 9. So negative 9 plus 9 is going to be 0. So there's our answer. X equals 0. So this last section is going to talk about two different types of equations that you could run into. The first thing we're talking about here is an identity. And an identity is an equation that is true for all values of the variable. So what that means is you can plug in any variable and it's going to come out true. And I'll show you what that looks like in a second. And then the second part here, some equations are always false. That means that they have no solutions. So let's take a look at what each one of these mean here. So this is an identity. This one where all the answers are true. When solving an equation, if you get an answer that's true, the original equation has an identity and it has infinite solutions. So if you look at the numbers here, 2 plus 1 equals 3, and on the right side 2 plus 1 equals 3, well, they're the same on both sides. If you look at algebra terms here, what you're going to turn out to have is if you're solving and you come out with no x, all the x's are gone, but you have the same number on both sides, that means any number you put in for x is going to be true. So if I put in 3 for x in this equation, I'd have 2 plus 3, which is 5, and on the right I would have 2 plus 3, which is 5, and they're still equal. Now, the opposite of that is when we have a false equation. So when you work it all out and you run out of x's, which can happen, and you have this answer here in the very bottom where it says 0 equals 3, and the numbers don't match up, that means that there are no answers for x that will make this equation work. So we'd have no solution. That's what we're going to write down when you see this in the end, no solution. So let's take a look at what some of these might look like. So here's our first example here. 10 minus 5x plus 1 and 7x plus 11 minus 12x. So we're going to do what we're supposed to do here and rearrange. So this is going to move over here and be a negative 7x. And this is going to move and become a, going to be short on space here, positive 12x. So those are gone and those are gone. This 10 is going to move, be a negative 10. This 1's going to move and be a minus 1. So we got a bunch of stuff all over the place here. Let's try to clean this up. So here's my 12x that was here, minus 7x, that's up here, and then the minus 5x that was already there. Now over here on the right we have 11, which is already there, the minus 10, which we had to move, and the minus 1. So let's combine like terms here. 12x minus 7x, that's going to be 5x. Minus 5x equals 11 minus 10. Oops, let's do that. 11 minus 10 is going to be 1. There we go. Minus 1. So 5x minus 5x, that's actually 0. There's nothing left. You start with 5x and you subtract 5x, you have 0. And 1 minus 1 is 0. So what you have here are the two same values on the same side. And that's okay. That means that our answer, any number we put in for x, is going to work out here every single time. So this is where we put all reals. Let's check out the next one here. This one, we have a little bit, not as many movements, but we'll have a couple here. This negative 3 is going to move over here and be a positive 3. And then two terms are going to come over. My goodness. This positive 5x is going to be a minus 5x. And this positive 8x is going to be a negative 8x. So let's rewrite this and make it look nice here. We have a negative 5x that we moved over, the negative 8x that we moved over. We're going to cross that out. Plus 12x that was already there, plus x that was already there. Those just came from right up here. Now our numbers. We have negative 4 plus 3. Alright, so we got a lot of combining to do on the left here to find out what's going on. So negative 5 and negative 8, signs the same, so we're going to add. That's going to be negative 13x plus 12x plus x equals, now I can do this, negative 4 plus 3, that's going to be negative 1. Let's keep going on the right here, negative 13 plus 12, that's going to be negative 1x plus x equals negative 1. And negative 1 plus 1, which is still kind of there, but you don't have to write if you don't want to, that's going to equal 0. And on the right side we still have negative 1. So in this case, our numbers are different. They don't match up. So they're not equal to. 0 does not equal negative 1. So this one has no solution. No matter what we plug in for x, we won't get anything equal on either side. So no solution for this one. Let's try this one. Moving some stuff around here. This negative 3 is going to, or positive 3 is going to over here and make a negative 3. And this 7 is going to go to the right and be a negative 7. So we've got everything arranged nice and neat here. Negative 3y plus 4y minus y equals 10 minus 7. So I got rid of that. Okay, negative 3 plus 4, that's going to be a 1y minus y equals 10 minus 7, which is 3. Y minus 1y, or 1y minus 1y, that's going to be 0 equals 3. And once again, these answers do not have the same value, so 0 does not equal 3. So once again, we have a no solution. No solution for these ones. Next one. We're going to move a few things around here once again. We got this negative or positive 3 is going to come over here and make a negative 3c. Get rid of that. And this positive 7 is going to come over here and make a negative 7. So not too many moves, which is nice. So there's that negative 3c, positive 2c, and then a positive c. And for our right side here, we'll do negative 14 plus 21. Those two are there. Minus 7 that we had to move. Okay, so let's do one side at a time here. Let's do negative 3c plus 2c. That's going to be negative 1c plus c. And then negative 1 plus this hidden 1 here is going to give us 0 again. Over here we got negative 14 plus 21. That's going to be a positive 7 minus 7. And then we have 7 minus 7, which is 0. So this one's good. This one's the same on both sides. They do equal, so our answer here is all reals. Okay, so now we're going to start looking at some word problems that come involved in this. And this one says, John and Sarah are planting tulip bulbs. John has planted 60 and is going at a rate of 44 bulbs per hour. And Sarah is planting 96 bulbs and is planting at a rate of 32 bulbs per hour. So how many hours Well, John and Sarah planted the same amount of bulbs. So John's moving a little bit faster, but doesn't have as many bulbs planted. Sarah has a lot of bulbs planted, but is moving a little slower. So what we're going to do is look at this equation here. So John, here it is again. John is working at 60 bulbs. Already has 60, but is moving a little bit faster than Sarah. So what we're going to do is design an equation here to figure out what this is and what it's going to look like. So we're going to use B for our letter. It's going to be for bulbs, and we're going to write an expression. So if you think about it in word form here, John, who has 60 bulbs, plus his 44 bulbs per hour, so that's where going to be our equation term, is going to be our variable term, is the same as, that's going to be equals, of course, 96 bulbs, Sarah's 96 bulbs, plus her 32 bulbs per hour. So if I'm going to write an equation for this, I'm going to write 60, that's the number of bulbs John already has done, plus he's doing 44 bulbs per hour. So that's kind of what B is going to be for, 44 bulbs per hour. And that's going to be the same as, or equal to, Sarah, who has 96 already in the ground, and she's going at an additional 32 bulbs per hour. These are kind of keystone questions you're going to see all of the time. So I'm going to move everything around. Sorry about that. We're going to move everything around, and we're going to take this 32 and bring it over here and make it a negative 32b. And I'm going to take this 60 and bring it over here and make it a negative 60. So let's get rid of this and get rid of this. Rewrite this real quick. Negative 32b plus 44b equals 96 minus 60. Okay, so I do some math here. For my left side, negative 32 plus 44, the signs are different, so I'm going to subtract and keep the sign of the bigger number. That's going to be positive. So 8, 9, 10, 11, 12. B equals 96 minus 60, which is 36. So I'm going to divide here both sides by 12. I'm going to have to write this over here on the side just a bit and get B equals 3. So after 3 hours, they will have planted the same amount of bulbs. Let's take a look at the next word problem. And this is one I see all the time. 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7. So how old is Greg? So if we let G here represent Greg's age, we're going to write an expression for his age. So we're going to work this out here block by block here. 4 times Greg's age, that's going to be G, minus decreased by 3 is going to equal 3 times Greg's age increased by, and that'll be a plus, 7. So if I'm using G for Greg's age, 4 times Greg's age, so that's going to be 4G decreased by, that's going to be minus 3, is equal to 3 times Greg's age plus, that's 7. Let me write that out. We'll space it out a little further here. Increased by 7. So what I'm going to do here is move everything around. 3G is going to go over here and make a negative 3G. And this negative 3 is going to come over here and be a positive 3. So if I rewrite this, I'm going to have to write it small here. 4G minus 3G equals that positive 3 we brought over plus 7. Well, 4G minus 3G is going to be G. Going to run out of screen here. 3 plus 7 is 10. Oh, just enough screen. So Greg, do a capital here. Greg is, we found G is 10. Greg is 10 years old. That wasn't too bad. So Greg is 10 years old. Okay, So that's it for this lesson. Here are a couple questions here to look at in the end. We have 5 normal ones we looked at, and then we have number 6 here, which is a word problem. Do your best. Write them down. Get them as, you know, if you have any questions, please let me know. Thanks again so much for watching. I do appreciate it. Have a great day.